Okay, welcome back. That was the answer for task 1. So moving on to task 2, it looks like this. Okay, if you could do that, please. Let me see how you get this done. I will reveal the answer shortly. You can pause the video and do it. Okay, so assuming you've done it, you pause the video, did it, and then you want to see the answer. Here we go. Again, we have here our truth table. All right, let me get that marker out. First row, second row, third. We have not A or B equals P. We have the normal A here, normal B is there, then the not A, and then we have a P. P is the same as saying not A or B. It's the same as P. Okay, so my start values, A, I've given A 1 and B 0. Then the next row, A, they're both 1 and 1. Then the third row, they're both zeros. And the final row, A is a 0 this time and B is a 1. Okay, so just keep changing the values. No need to repeat them because you're going to get the same results. Okay, so those are the possible values I can have. Not A, so we're going to change the A's. Okay, not A is a 1, not A is 0, A is 1, not A is 0, and again A is 0, not A is 1, A is 0, not A is 1. Now after finding what not A is, now we're going to concentrate on these two, B and the not A. So we're going to use the OR gate. Now remember, this is the OR gate because it's a V, it's not N or AND. So OR gate. All right. Now, not A or B, because they're both zeros, the answer will be a 0. The O answer here, one of them is a 1, this is a 0, so that's why we have a 1 as our result. Again here, all right, the not A is a 1, so the output is going to be 1. They're both 1, and remember the OR gate only requires one of them to be a 1 to give a 1 result. So our results here, we have 0, 1, 1, 1. And let's see the images here. The first one, where this is A, okay, and this is a B, all right. Remember, we're going to start with the NOT gate, which is not A. So this is not A. Now remember, A is a 1 here. So A is a 1. When it goes through the NOT gate is going to change that 1 to a 0. So it's going to output a 0. And then B is a 0. Okay, 0. So we're using an OR gate here. We're using an OR gate, all right, or a plus sign. So we have a NOT gate giving us a 0, but also have a B giving us a 0, which is why you see this here, okay? A was converted to 0. So the OR gate will give us a 0 because it doesn't have any positive input. That's why the bulb is off. On the second row, okay, so this is the first row, okay? This is our second row, all right? This diagram, where A here is a 1 and B is also a 1, okay? A is a 1 and B is a 1. So that's 1, that's 1. The NOT gate is going to change it to a 0, this NOT gate, okay? Because that's a NOT A. So when they go through the OR gate, this time let's use a different sign, which is a plus, the OR gate, all right? The OR gate expects one of them to be on. So because B is on, the OR gate is then gonna give us a 1, hence lighting up the bulb. Okay, so moving to this one here, and this will go there, all right? This one, A is 0 and B is 0. As you can see, A is 0, B is 0. Okay, that's A and this is a B. The NOT gate is going to change this 0 input to a 1 output. That's what the NOT gate does. And because the 0 is coming from the B towards the OR gate, the OR gate expects one of them to be on for it to give a positive output, which is a 1. That's why you see the bulb is on. Number 4, fourth row, our next sample was a 0 and a 1, A being a 0, B being a 1, but the NOT A gave us a 1 here. That's a NOT A, which means NOT A or B, these two here, one of them has to be on. So remember, this is A and this is switch B. A being a 0, switch B giving us a 1 here. Okay, the NOT gate is going to invert this 0 to a 1. So the OR gate expects one of them to be on. They're both on, which is fair enough. The OR gate therefore going to output a 1. All right, so that's our truth table. And those are the diagrams you see there. So these diagrams here, they represent each row of the truth table. All you have to do is to organize them so that the OR gate, which is this one here, corresponds to this NOT A. NOT A, I mean the NOT gate here is for NOT A, okay, the NOT gate, and the OR gate is the one over here. So you have NOT A or B, NOT A or B, and if you join them here at the OR gate, that's the result you get. The same applies to all the other symbols. Read through this text and then we'll move on to the next question. So like I said, the output can be any letter. This is always going to be our output, which is also the light bulb. This is what comes through to the light bulb, which is P here, or that's our P. So you pause the video. I am going to move on to the next one. Draw the truth table for this diagram. Okay, now I expect you to somehow work out the actual equation, the Boolean equation for this. Let's say this is a B, this is switch A, and this is switch B. Now you should know what these symbols represent. You should remember those. And this is our output C. So what answer do you have for this? If you can, also explain why the bulb is on. Also talk about what this gate is doing. Okay, why are they looking like this? Talk about this gate as well. Pause the video, do this work, and I am about to move on now. So here's our answer. I mean, with the explanation, I will tell you the explanation, okay? But I only took one sample here because it's the one that is relevant, okay? Now, I have A here and I have a B. This here is a NOT gate. So this would be NOT A, all right? And this is an AND gate. Now remember, AND, N, letter N, AND, or there's full stop there. Some people call it period, okay? Now this is our AND gate, this here, all right? Now, what's happening? A has a 0, as you can see in our truth table. A has a 0 and B has a 1. So A has a 0 there and B has a 1. And what does the NOT gate do? It inverts this 0 into a 1. Okay, it converts it to a 1, whichever way you want to use it. Okay, you want to say it. Okay, the NOT gate is going to turn this A, which is not A. A is a 0, but what is not A is 1. Because remember, in binary, it's either a 0 or a 1. So what is not a 0 is a 1. And what's not a 1 is a 0. So understand NOT gate like that. Okay. Because B is a 1 here, because the switch is on, that means it's a 1. If we combine this with an AND gate, okay, we're going to have a positive output because AND gate is expecting 2 1s, all right, to give a 1 out, all right? So that's why you saw this truth table. So this is correct, and this, if you got this right, mark yourself. And here's the equation. We're going to say NOT A, put a dash there, okay? And now you can write it like this: NOT A and B. NOT A and B equals, make up your own result. I use the C as my result. Or you can write it as NOT A and B. Let's make this dot very obvious. And B equals C. So that's how it is. That's your task 3. we're moving on now. That's how we do it. Task 3 look like that. That's our answer. Explain why one bulb is off and the other is on. Now, I'm not asking you to draw a truth table because this is a very complex diagram, okay? However, you need to remember the logic gates just to make it look easy, okay? I'm gonna label this A. Explain why Y is on and X is off. Why do you think that's happening? Look at it and find out and find the way of explaining this. I'll reveal the answer in a minute. Pause the video and study this diagram. Okay, so I'm about to reveal the answer. What's happening here? Now, you can read this if you want to. Okay, I put down some notes for you. If you wanna, put this in a book or whatever, it's up to you. But the easy way to understand it is, we have different gates here. There's one we haven't seen so far. This one here. What happens? This is called an exclusive OR gate. This here is called exclusive OR. This, remember, is an AND gate. This here. Same with this. Let me make it interesting. Put some different symbols here. Now, what's happening? Switch A is off. Okay, now it's giving us a 0 here and a 0 there. Switch B is on, which means it's giving us a 1 there and a 1 there. Same with switch C. Switch A is giving this 0 to an exclusive OR gate and also to this down over here to the AND gate. So switch B, the exclusive OR, is also receiving a 1 from switch B. Now what is an exclusive OR? This one only allows one input with a positive charge for it to output a positive charge, which is why, because only B gave it a positive charge or gave it a 1, only B is turned on and A is off. That's why it's giving out this 1. If A was on, the exclusive OR would have given out a 0. The same applies here. This exclusive OR is receiving a 1 from C, and also it's also receiving 1 from this exclusive OR. So the first exclusive OR gate is sending a positive charge to the next exclusive OR gate. Now when this one gets two 1s, it only accepts 1 and the other has to be a 0. It's going to give a 0 here. That's why this bulb is off. B outputs a 1 to the AND gate. The AND gate is also receiving a 0 from A up here. Okay, so this AND gate will give a 0 output because AND gate expects both of them to be on. That's why it's giving us a 0. So this 0 goes to the OR gate. This other AND gate is receiving a 1, this 1, from this top, the first exclusive OR gate. Okay, it's also receiving, this AND gate is also receiving a 1 from C, receiving this 1 here that comes from C. Because the AND gate is receiving both 1s from these inputs, it's going to give a 1 here. You see that little 1 here, that blue one? It's going to give a 1 here, which joins with this 0 here, coming from the AND gate to the OR gate. The OR gate only requires just one input to be on. Even though this is 0, OR gate is going to give you a 1. And that's why the light bulb is on. So that's how you study this diagram. That way it should be easy for you to explain them. So that's how it is. Now, thank you very much. Sorry, my time is up. That was task 4. Thank you very much.